This is students a continuation to our first video about introduction to vectors. So we have a question given that P is 6, 4, Q is negative 5, 3, and R is 3, negative 4. Find the column vector of PQ and RQ. So I'm going to have my PQ. How do I define PQ? Remember, as part of your work, if I'm saying it is vector P, then Q, it means I'm moving from P going to Q. To find this distance it will be I'm moving from P going to Q. To find this distance from P to Q, I get where I have reached, which is at Q, minus where I'm from, which is at P. But what I do is I use what we call the position vectors that we talked about, such that I can say the position vector of P, which is OP, will equal to, so I can have it as 6, 4. And then the position vector of Q, which I can call OQ, this will equal to a negative 5 with 3. And then you can get very happy, or you can get very excited and say that this is still, I'm telling the direction of these guys in relation to the origin, moving from the origin to a point P, such that PQ, in most cases in the questions they will be in bold, but then when you're working with them you can put their arrows, meaning PQ is where I have reached, which is at Q. So this is OQ minus where I am coming from, minus OP, such that I'm going to be having this as a negative 5, 3, and I'm taking off a 6 with 4, such that I'm going to have this as negative 5 minus 6 and then 3 minus 4, such that this goes to negative 11 and then negative 1 as my PQ. So as part of the work, you can, as a student, you can try out RQ. You can try out RQ. So I'm going to assume you have tried out RQ. We can move to another small subheading that we are calling multiplication of vectors, or multiplying vectors by constant stroke scalars. A scalar is simply a constant, and what happens is the scalar multiplies each component of a vector. If I have my vector, maybe A, that is equal to 2, 4, and then they tell me to find K, A. My K is the scalar. The scalar is going to multiply each component of vector A. In other words, my KA would equal to, I have there K multiplying by vector A, which is 2, 4. But what happens is my constant K multiplies each component of my vector. In other words, I will have here 2K, and then K times 4 is 4K. That is the vector multiplication by constants or scalars. So if we can look at a better example, so we are saying, if we can look at a better example, we have such an example that given that vector B is equal to negative 5, 11 and A is 3, 4, find the value of 3A plus a half vector B. So we can have our 3A plus a half of my vector B. This will equal to 3. Give me vector A. Vector A is 3, 4 plus a half. Get me vector B. Vector B is a negative 5 with 11, such that the scalar multiplies each component of a vector. I have 3 times 3, then 3 times 4 on the first part, then plus, open brackets, I have a half times negative 5, and then a half multiplied by 11, so that I have this is going to be 9, then this is 12, then I'm adding 1, this is going to be negative 2.5, and then I have this is going to be a 5.5. So I add, we said when you're adding vectors, we are adding the corresponding components. So I have 9 minus 2.5, and then I have a 12, then plus a 5.5, such that I have this as a 6.5, I have it as a 6.5, and I have this as a 17.5. So that is the vector multiplication by constants, or what we call scalars.